Hello. So what we're going to do now, I'm going to go through and basically I just want to go over the answers with all this stuff. So I'm going to go through and do like selected answers to these problems. I'm not going to do every single one of them, but I'll have the answers for the rest of them. And I'll post the PDF of this thing that I'm going to write out. But I just wanted you to also have a video of the work there in case you needed help with anything. So I will be going a little faster through this. I'm not going to really be like commentating. I'm just going to be like doing it for you to look at, and then I'm assuming that you have some idea where all the variables are coming from, like the equations and all that, and, from the slideshows and the notes and all the other videos and all that. So just understand that. So I'm just going to sort of start working through this. Follow along, skip to whatever you need to see, and there you go. Key here. But anyway, yeah. So it's frequency. So this first problem wants frequency. It tells us that we have a wavelength of this, so we're going to be using this formula. All right, so we'll rewrite it. We'll just move this frequency, so we'll move wavelength to the bottom over here. So our formula is. I'm just going to be writing out the variables. I'm not going to keep rewriting like 3 times 10 to the 8th, and I have it programmed in my calculator. Anyway, well, actually, we'll see. I just changed the battery, so I might not have it programmed in anymore. I might have to redo it. This will just be so. Okay. Easier to see the screen of a calculator. Yeah, whatever, I guess you can see it. Don't forget to use parentheses when you divide. The most common mistake that people make. So our answer here is 2 times 10 to the 14th. That would be meters there. Your meters will cancel. 1 over seconds or hertz for frequency. So there's the first one. Just keep going. Should be a way to like increase the brightness. Anyway, whatever. So let's keep going. So you're going to look through this, and it says here you got your wavelength. It wants frequency in this case. So we've got our C is equal to wavelength frequency. In this case, we're going to move wavelength. Oh, it wants frequency again. So we're going to move frequency to the bottom again. Wavelength to the bottom again. And our formula will just be C over wavelength is equal to frequency. Cable. And then we'll just do this. So in this case, that'll be so you get a frequency here. We'll say 2.61 times 10 to the 18th, 1 over seconds again. Cancel out meters, or you can write hertz. I don't care. All right. So number 3, it's the same deal. I'll post that answer on. Actually, I'll just do it. I'm not going to write all the work for that. Oh, actually, this is a little different. Well, you're solving for frequency, so I'll do this one. So in this case, the formula is you're solving for wavelength, so it's different. So in this case, the formula is going to be C over frequency is equal to wavelength this time. So it'll be 3 times 10 to the 8th meters per second. Remember, hertz is 1 over S. I'm going to rewrite it like that. So you'll do divided by. If you're getting these answers, but the exponents are wrong, then you're not using parentheses when you divide. So 38.46 meters. All right. So there you go. Oh, and that you can't see the meters. All right. So you can solve this looking here. I'll put the answers. So this wants wavelength, increasing wavelength. Remember, so in this case, you have frequency gets bigger over here. Now, remember, wavelength is inverse to frequency. So if you would imagine wavelength up here, you would realize that wavelength would then be going that way. So wavelength would be decreasing that way. All right. So then you would go through and identify what's biggest, what's smallest. And then here, this is just asking you to identify these on the chart. So you can do that, like just saying, like place them where they would fit. These conversions, these are a little weird here. I understand that. So if you weren't able to convert, and you should convert, nanometers, you have to convert this to meters. So this is going to be, that one's a little tough for you. So you would do 4.2 nanometers, meters, 1 meter, 10 to the 9th. That's going to equal basically 4.2 times 10 to the negative 8th meters, and that's your wavelength. You would then have to convert that to frequency and figure out where it falls on that spectrum for the sake of just time. So that would be equal to the frequency of 7.14 times 10 to the 15th hertz. So you have to find 10 to the 15th. So realistically, that looks like it'd probably be kind of like right in the visible light spectrum right here, realistically. And I mean, that kind of should be sort of right in there. So frequency would 10 to the 11th. That would be right around here. That would be like a microwave. And then, so you can say micro. This would just be, I would just classify this as visible light. Though that's not totally right, but that's like pretty much right in there where you'd expect it to be. And then with a frequency of 5.6 megahertz. So honestly, I didn't tell you how to do that conversion. I'm not going to force you to do that one. If you did it, good for you, but you don't need to do that. So let's keep going down here. So what is the wavelength of frequency of this? So it gives you a frequency, so you're just going to do so you're basically just doing C divided by 5 times 10 to the 12th. That gives you 6 times 10 to the negative 5th. Wavelength, and then identify what type it is. You can just do it based on up there. So that's like microwave, based on its general location right there. Or you could say infrared, I guess, more than micro, so you can say infrared. You keep going. So what is the frequency of electromagnetic radiation having a wavelength of this? So same deal. You're just going to do, in the end, basically, if you're starting to realize, like if you're given a frequency or a wavelength, all you do, and it wants the other one, all you do is divide by, C divided by whatever it is. So that'll give you, say, 9 times 10 to the 15th. So okay, so what type of this? Go find the 15th again, and you're kind of right in this this middle thing where it would be sort of the visible spectrum close enough. That's the front side. All right, back side now. So the rest of these, I'm just going to sort of start working through these. So keep watching. Again, I'll post the PDF of this. So this temperature here, that doesn't mean anything to you. Don't worry about that. This is a long problem. You're going to convert 4.5 times 10 to the second nanometers. You're going to have to first convert that to meters. So to do that, you'll do 4.5 times 10 to the second nanometers. You're going to divide that by 10 to the 9th. That part is confusing. Yeah, that's understandable. So you'll end up with, but so like don't freak out if like this little bit is like the nanometers thing throws you over the edge a little bit. Like it's okay. So it'll be 4.5 times 10 to the negative 7th meters, and you're going to convert that now. That's your wavelength. You need to convert that all the way to energy. The only way to do that is to use both equations. All right, where you're going to be using C is equal to wavelength frequency, and energy is equal to Planck's constant times frequency. So you've got your energy, or you've got your wavelength. You're going to plug it in here. You're going to solve for frequency, and then you're going to solve for energy. So our formula will be C over wavelength is equal to frequency. So we're going to do C divided by 4.5 times 10 to the negative 7th. For space, I'm just writing it like this to kind of move it along. Remember, C is 3 times 10 to the 8th meters per second. That will give us our frequency. So we'll do that. We'll do. Remember, parentheses, always parentheses. That'll give us, we'll say, 6.67 times 10 to the 14th, 1 over S. That's our V. Now we're going to plug it into here. Remember, H is a constant, so then our energy is going to be equal to H. So I'm going to rewrite it out. It's 6.626 times 10 to the negative 34th J times S. I can't write small. That's H. Now our actual formula is going to be equal to E H. I'm just going to write it like that. Remember, this number gets plugged in right there, times our frequency. So our formula is equal to HV. So it's going to be E is equal to H times our frequency, which is 6.67 times 10 to the 14th, 1 over S. So our energy is equal to 6.6. Is 4.42 times 10 to the negative 19th joules, because your seconds and cancel. So then 9 you can't tell what's orange. I can't tell what's orange. So whichever one's orange, you would figure out. I would guess it's maybe that one. I'm not sure. I can't tell on this stuff, so I'm not going to do that part. And then I'm just going to fill out the rest of these pretty quickly here, sort of seeing. So in this case, the wavelength, or no, so the frequency here would be so yeah. So we're going to get that. There's no way. So for this one, this is a little different, so I'll show you this one. So energy is equal to H times V. Energy is equal to Planck's constant times frequency. In this case, you've got your 2.93 times 10 to the negative 25th. That's your energy. So you're going to do energy divided by H is equal to frequency. So I did in the calculator here. So you can see I have H programmed in. You should program it in yourself again. And you're going to find that your frequency is this number. I'm not going to write that out. 1, 2, 3, 4, 5, 6, 7, 8. So 4.42 times 10 to the 8th. 1 over S. Remember, that's our units hertz. So that's our frequency. You can go identify what it is based on the chart on the other side. Let's see. So you can see this. So I'm doing this one. So that's our energy. And we're going to solve for frequency. So we're going to do that's our frequency. Speed of light divided by our frequency. That gives us the wavelength. So 1.8 times 10 to the negative 12. I don't particularly care if you identify what type of radiation this is. The main thing, like I said, is understanding how to do this math. I'm less concerned with the identification. I know you can read a spectrum and identify something where it is based on the number. So these are all just asking you to find energy. I'm just going to go do these really fast. Just when you see S to the negative first, understand this is a frequency. S to the negative first equals 1 over S, which equals hertz, which equals frequency. It confuses kids. So just know, though, that S, it's just the same. It's all frequency. All right? Don't think it's anything other than that. So you're just going to basically, for the two that are frequency, you're just going to multiply them by H. For the one that's wavelength, well, this one identifies frequency too. They're all frequency. So you're just going to actually multiply all of these by H to get E. It's actually pretty simple. That's a really low energy. Some of these numbers you're going to get, like they're just numbers. Don't worry if they seem weird or you're like, these are small or big. Like, they're fine. It's not like a thing you need to be really concerned with. So actually, I'm going to write it down here. So A, the units here is 4.19 times 10 to the negative 13 joules. That's energy. So this is going to be 6.29 times 10 to the negative 20th joules. And this is 1.05 times 10 to 16. Pen all over my hand. This one will round, we'll say 6.9 times 10. So all three of these, all I did was just do E is equal to HV. H is the constant number, Planck's constant. V is whatever's given to you here, so you just multiply them together, and that's where you got your answer. All right, hope that helps. Please email me if you have questions.